So in today's class we are continuing with our exercise 2.5. First question number 12 we are solving, and after solving it we will use it as identity number 11 for next question. So we are starting with RHS first. As you know that in our RHS, according to question, it is given to us that half into x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. Now in next step you can see that we have first solved our second bracket, in which we have solved x minus y whole square, y minus z whole square, z minus x whole square according to identities. So after solving we will get half into x plus y plus z as it is. Then in our second bracket we will get x square plus y square minus 2xy plus y square plus z square minus 2yz plus z square plus x square minus 2xz. Now in next step we will see that we'll write half into x plus y plus z as it is. In our second bracket we will combine x square with x square, as these both are only the like terms here, so we can add it, so we'll get 2x square. Similarly y square will be added in y square, z square will be added in z square, and rest of it can be written as it is. So we'll get as 2x square plus 2y square plus 2z square minus 2xy minus 2yz minus 2xz in our second bracket. Now in next step we will first copy half into x plus y plus z as it is, but we'll see here that in second bracket 2 is coming common, so we'll take 2 common from second bracket. After taking 2 common from second bracket, we can observe here that all of the number digits, or you can say all of the given numbers, are in multiplication now, so we can just cut our 2 with 2. So after cutting it we will left with only x plus y plus z into x square plus y square plus z square minus xy minus yz minus xz. Now after this we will observe that this is the identity number 10. So from identity number 10 we will get x cube plus y cube plus z cube minus 3xyz. Now we will see our LHS of the question. According to LHS of our question, we will get x cube plus y cube plus z cube minus 3xyz. So after this we can say that LHS is equals to RHS, hence proved. Now we are solving our question number 13. Similarly, we will first solve it and then we will use it as identity number 12 for next question. So here in this question it is given to us that x plus y plus z is equals to 0, and we have to prove that x cube plus y cube plus z cube is equals to 3xyz. So for this we will have to prove x cube plus y cube plus z cube is equals to 3xyz. Now in next step we can just modify our to proof, that is x cube plus y cube plus z cube minus 3yz is equals to 0 we can write. That means we have just shifted our RHS to LHS and name this whole equation as equation number 1, so that we can prove first equation number 1. As we know that it is given that x plus y plus z is equals to 0 to us, so we will use it in our in solving this question. So first we are starting with RHS. RHS of the modified to prove is x cube plus y cube plus z cube minus 3xyz. Now here you can observe that we can just we can just expand it with two identities. So I have done it with both the ways. First I am explaining you according to identity number 11. So if you open your this RHS according to identity number 11, you will get half into x plus y plus z into x minus y whole square plus y minus z whole square plus z minus x whole square. Now in place of x plus y plus z we can write 0 in the next step, as we know that it is given to us that x plus y plus z is equals to 0 in the question. So if we put this as 0, and we know that 0 into something is 0. So if we solve it further, we'll get answer as 0 only. Now if we use, or if we solve this RHS with identity number 10, then we can write it as x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Similarly, we can put in place of x plus y plus z as 0, as it is given to us, and 0 into something is 0. So we can use any of above identities and solve this RHS. Now we know that LHS of our modified 2 proof is 0 only. So we can say that LHS equals to RHS. Hence equation number 1 is proved. That is x cube plus y cube plus z cube minus 3xyz is equals to 0. So we can, from here we can say that x cube plus y cube plus z cube is equals to 3xyz. That is, we can just shift our minus 3xyz to another. Now one example on identity number 12. Example number 1 is, without actually calculating the cubes, we have to find the value of minus 13 whole cube plus 8 whole cube plus 5 whole cube. So we will first consider x as minus 13, y as 8 and z as 5. So if we add this x plus y plus z, then we can observe that if while adding we are getting it as 0. So if, as we know that according to identity number 12, which says that if x plus y plus z is equals to 0, then we can write x cube plus y cube plus z cube as 3xyz. Similarly, we can write our given question as 3 into minus 13 into 8 into 5. And so answer is minus 1560, that is minus 1560. Now come to example number 2. In our example number 2, we have to give possible expression for the length and breadth of rectangle in which its area is given as 3a square minus 4a minus 7. We will find factors by splitting method. In this, we have to find factors first, and after finding factors, one factor will be the length and second factor will be the breadth. So by splitting method, our factors it will be that we can split it into that is, we can split 3a square minus 4a minus 7 into 3a square minus 7a plus 3a minus 7. Then in next step we can take a common from first two terms, and inside 3a minus 7 will be left. In next two terms, 1 is coming only common, and inside 3a minus 7 will be left. Now in next step we can see that 3a minus 7 is coming common in whole, and what is left with us, a plus 1 will be left in one bracket. So we will, as I have told you, that our first factor will be length, second will be breadth. So here length will be acting as a plus 1 and breadth will be acting as 3a minus 7. Now you can solve your exercise 2.5 question number 14 to question number 16. This is your assignment, and after solving you can take your doubts.